Hi everybody, welcome to the next video. So in this video we're going to be looking at plotting straight line graphs and finding the equation slash gradient of the line. So let's dive straight in and have a look. The first thing you're going to be looking at is the fact that we have an equation of a line here written in the correct format. Now the correct format should be y equals mx plus c. Key thing to remember is that this part here is your gradient and this bit here is your y-intercept. Now, if you are ever given an equation that is not in that format, so let's take a different example. For example, if I said to you 2y plus 6x is equal to 8, if you were given that as an equation of a line, that's not in the correct format. So therefore, to get that in the correct format, it must have the y at the start. So what you would need to do is you need to take this x over the other side, and where it's a positive 6x there, it becomes a minus 6x when you move it. So you'd be left with 2y is equal to minus 6x, and then I can just shift the 8 and put it after that. It doesn't matter if I put 8 minus 6x or 6x plus 8. They are the same thing. And then I still need to get y on its own. So in order to get rid of this 2, I divide all this by 2. So y is equal to minus 3x plus 4. So if you're given an equation of a line that is not in the correct format like this, and it's something like this, make sure you rearrange it first of all to get it in the correct format of y equals mx plus c. I'm going to delete that because we're not using that part for this question. But let's look now at what we need to do. So the problem is that I haven't got a table. So if you aren't given a table, it tells you what to use your table values. So what you need to do is you need to create your own. So you go x and y, and you create the table yourself here. You start at minus 3, then we go minus 2, minus 1, 0, 1, 2, 3. So this would be my table that I would create. Now sometimes in an exam you get given the table, but because we're not given the table, I'm going to create it. From here, there's a couple of things we're going to do. So I'm going to talk you through the proper process and what we do first, but then I'm also going to talk you through a shortcut that you can use as well. Now, this equation here means 3x minus 2 means 3 times x minus 2. This is my first value of x. So all I do is I take the equation. So the equation is y equals 3x minus 2. And all I'm going to do is I'm going to change this x value for minus 3. Now 3x means 3 times x. So I'm doing 3 times minus 3 and then minus 2. Well, work this bit out first. 3 times minus 3 is minus 9. Minus 9 minus 2 is minus 11. So my number here would be minus 11. Okay, let's see what happens in the second example here. Now we're looking at x being minus 2. So I still use this equation here that I've got. And I say 3 times, now x is now minus 2. So I take this minus 2 and change that x for minus 2. And it becomes 3 times minus 2, then minus 2, which is minus 6, this first bit. Minus 2, minus 6, minus 2 gives me minus 8. Okay, now pause the video and have a go, see if you can get the last ones in, see if you can figure out what to do for each one of those, and then I will go through it. So what you should end up having is 3, so for the next one I'll do it in pink, so you have 3 times minus 1, then minus 2, well that becomes minus 3 minus 2 is minus 5, so minus 5 would go there. Then what we end up getting is 0 for our next one. Well, this is pretty simple because you're saying 3 times 0, which is just 0, and then minus 2 is minus 2. What you will notice is whatever the number is here, this is called your y-intercept, will always be underneath 0. So that's a little trick you can use. Let's finish this off. So next one would be purple. So 3 times 1 minus 2. Well, 3 times 1 is 3, minus 2 is 1. And then the next one I'll do in grey. So we've got 3 times 2, which is 6, and then minus your 2 is 4. And then the last one will be 3 times 3, which is 9, minus 2 is 7. So that should be what you end up having as your table. Now what I'm going to do is I'm going to show you, I'm going to remove this and remove this working out up here. What I'm going to do is I'm going to show you a shortcut we can use. So if you're ever not sure and you get stuck with the maths, what you can basically do is say, okay, the y-intercept is -2. So I put that underneath 0. Okay, so whatever this is goes under 0. Okay, now this next part, the 3x, is the gradient. So this is what it goes up by. Now what I mean by that is, if I start at -2 and I work this way, I add 3, I end up with 1. If I add 3 again, I end up with 4. If I add 3 again, I end up with 7. If I then go this way, I subtract 3. So that gives me -5. Subtract 3, -8. Subtract 3, -11. So your shortcut here is to go whatever this number is, put underneath 0. Whatever this number is, if it's a positive, it goes up by that number. If it was a negative, it would be going down by that number. So if it was a -3, I'd be doing -3 -2 -3 here. But because it's a positive, I add 3 this way, and then when I go the other way, I subtract 3. Okay, so that's your shortcut. If you're not sure about what to do with the maths, that's what you can do. So now what we need to do is plot this graph. So this table of values gives me all the information I need to plot this graph. So the first coordinate you're looking at is -3 on your x-axis, which is here, and then -11, which is all the way down here. So my first point that I plot, so if I just zoom out so you can see it, is -3, -11, which is all the way down here. -3, -11. The next point is -2, -8. So I go to -2, down to -8, plot that point, -1, -5 is my next point, 0, -2, and what you can see is that that actually crosses my y-axis at -2, which is what we said the y-intercept was. 1, 1, 2, 4, and then 3, 7 is up here. So quite a big graph, but what you can actually see is that that creates a nice straight line, and finally all you need to do is get your ruler, join all those points with a straight line, and what you should find out is that your ruler should cross every single one of those points. If your ruler doesn't and one of the points is off the line, it means you made a mistake. Okay, so normally you'd get a mark for the table at least, and then you'd get 2 marks for doing the graph correctly, 1 mark for drawing the line, 1 mark for plotting the points. Okay, so that's how you plot straight line graphs. 2 different ways of doing it. You can either substitute in the values like we've done, which will help you when we talk about quadratic graphs, or you can actually use our shortcut here, taking that -2, put that under 0, and then whatever the gradient is what it goes up by. Okay, so in this next part of the video, we're going to reverse the process, and we're now going to look at how we find the equation of this line. So what I mean by equation is we're going to need to find the gradient, and then we're also going to need to find the y-intercept, because we know that a graph must be in this format, y equals mx plus c. The mx represents the gradient, and the plus c represents the y-intercept, which is what we were talking about in the previous part of the video. So let's look at this question here. On the left-hand side, I've got a red line here, and the question would say, find the equation of this line. Now, looking at that, I can see that there is a clear point here where it crosses the y-axis. This is your y-intercept. So straight away, if I look at then writing the equation of this line, I know it's going to be something x, because I don't know what the gradient is, and then my y-intercept is at this point here, which is -1, so it would be -1. So I've filled in that part of the equation. I now just need to find the gradient. So to find the gradient of any line, what we do is we do use this formula. It's change in y divided by change in x. Okay, let's see what I mean by that. If we go back to our graph, we choose this point here that it crosses the y-intercept at, and then I can choose another point along this line. Now, when you're choosing another point along this line, it's important that you choose a point where it crosses perfectly on a corner. So I could choose this point, I could choose this point, or I could choose this point. I can't choose this point because it sits in the middle of a square. It's not a full coordinate, it's not an integer coordinate. So I have to choose one where it crosses perfectly in the corner. So I'm going to choose this one at the top, and then I'll show you how it works if I was to use a different value as well. What you then do is you draw a triangle between the points, and I count how many squares up that has changed by. So starting from this corner, 1, 2, 3, 4, 5, 6. That has gone 6 squares up. Now it's really important that you double check your scale that every square represents 1, which it does in this case because it goes 1, 2, 3, 4, 5. And also double check your X scale here across that each square is 1, because sometimes it might be 2 squares is 1. But in this case, my X change here is a change of 3. So now I look at this formula over here on the right hand side. The change in Y is 6. The change in X is 3. So my gradient is 6 divided by 3, which is 2. I then take that value and put it up in the top. So the equation of this line is Y equals 2X minus 1. Okay, now let me show you what I mean when I say it doesn't matter what points you choose on your graph as long as you choose full coordinates. So if I now was to pick 2 different points, let's choose this top point up here and let's choose this bottom point down here. And I now draw my triangle going down here and going across here. Let's count how many squares up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I go 12 squares up. So my change in Y is 12. And my change in X, 1, 2, 3, 4, 5, 6, is 6. 12 divided by 6 is 2. So I still get the same gradient. So it wouldn't matter which 2 points you choose as long as you choose 2 points that cross perfectly in the corners of the coordinates. Final way of doing it is you can choose any point. You go across one value. So from here I go across 1, that takes me to 2. And then you count how many squares up it is until you get to the point again. So 1 across and 2 up means my gradient is 2. Okay, so that's the third way you could potentially look at it. So as long as you choose 2 points where it crosses perfectly, that will give you your gradient. And remember, it's got to be in this format. So you have to add the y-intercept at the end, which is -1 in this case. So if you want to now, pause the video, see if you can have a go at working this one out, and then unpause it, and I will go through it with you. Okay, so again, let's write down the y equals mx plus c, and straight away fill in what we know. Well, I don't know the gradient yet, but I do know that the y-intercept here is at -2, so I know it's going to have a -2 at the end. Let's choose another point. So I've chosen that point there. If I follow my way along this line, I can see that point there crosses again. I can see this point here crosses, and I can see up here it crosses. So I can choose any one of those points. I'm going to choose this point here and this point here to work with. So I now draw my triangle between the two, and I count how many squares up I go. So 1, 2, 3, 4, 5, 6. So that is a change in y of 6. 1, 2. That is a change in y of 2. Change in x of 2, sorry. So remember, change in y divided by change in x is my formula. Change in y is 2, and my change 6, sorry, and my change in x is 2. 6 divided by 2 is 3. So this would be 3x. However, you've got to remember now that the graph is going down. Because the graph is going in a downwards direction, it becomes -3. Okay. The other way you can think about it is that your change in y, so your gradient has to now become -3. Okay, so if the line is going in a direction like this, it will be negative. If your line is going in a direction going up, it will be a positive. So that's why this gradient here is a positive 2x, because the line's going up. This gradient here will be a -3 in this case, because the line is going down. Okay, in the next part of the video, I'm going to show you how to do this when you don't have the graph, but actually what you do have is 2 sets of coordinates. Okay, so moving on, we're now going to look at these 2 examples here. What you notice is straight away we don't actually have the graph drawn, but we have got 2 points. So we can visualize this. If you think about what the graph would look like, if they were my axes, 0, 4 would be there, and then 3, 13 would look something like that. So my graph would end up doing this. Now, the concept's still the same. I need to find the equation of this line like this. Y is equal to mx plus c. So the first thing I can fill in this question is this bit. Okay, so I know where the y-intercept is because I've been given this coordinate here. This coordinate's really important. Where the x value is 0, the y value is 4, which is at this point here. So I know that this would become my y-intercept. Because that's 0, 4, I can say that my y-intercept is actually 4. So I know that this equation will be y is equal to something x, so I'll leave that blank for now, plus 4. Okay, now let's go back to what we spoke about a second ago in the previous part of the video. I need to find the gradient. So gradient is equal to change in y divided by change in x. Okay, now if I know the coordinates, I can use them to help me. So if you're given the coordinates, what you do is you then write them out one on top of each other. So 0, 4, and then 3, 13, and my two coordinates are right on top of each other. Thinking about what they represent, this represents my x value and this represents my y value. Because remember, with coordinates, 0 is my x movement, so I go 0 left or right, and 4 is my y movement, I go 4 up. Same for this, I go 3 across, so that's x is 3, and my y coordinate is 13 up. So that's why I've set them up like that. Now what you can do is you can go, okay, what is my change in y? How do I go from 4 to 13? Well, that is a change of plus 9. And how do I go from 0 to 3? That is a change of plus 3. So by doing that, this bit here represents your change in y, and this bit here represents your change in x. Take those two values, substitute into your formula up here. So my change in y is actually 9, because that's my change there. And my change in x is 3. So 9 divided by 3 is 3, and therefore your gradient becomes 3x. So your formula is y is equal to 3x plus 4. If you wanted to check that that makes sense and that works, you could substitute in any one of the coordinates. So let's choose this second coordinate. I know that x is 3, because that's the first value. X would be 3, y is 13. So let's substitute those into this question. So change y for 13, because that's 13 there. Let's change x for 3, which means I'm doing 3 times by 3, because 3x means 3 times by whatever x is, and x is 3 here. Then plus 4, well, 3 times 3 is 9, 9 plus 4 is 13, so I know that this equation works for that coordinate up there. Okay, let's look at the next one. Now, what you can do is you can pause the video again here, and you can do the process I've just done here and here to find the gradient. What you will notice is, though, that you haven't got a 0 value like we had here. Because this x value was 0, that value is my y-intercept. But in this case, we don't now have the y-intercept because I haven't got an x value of 0. So the first thing you can do is still find your gradient, and then I'll talk you through how to find the y-intercept part in a second. But pause the video, have a go at that. Try and find for me the gradient of the line first of all. Okay, so let's write the coordinates out above each other. So 2, 5, and then 5, 11. Remembering that that's your x, that's your y. Well, what's my change in y? How do I go from 5 to 11? I add 6. And how do I go from 2 to 5? I add 3. Going back to what we did before, this is your change in y. This is your change in x. So therefore, substitute that into the formula that we've got at the top. So change in y divided by change in x gives me a change of 6 for my y, because my change in y is 6. My change in x is 3. So therefore, the gradient of this line would be 2x. So what I can say is y is equal to 2x. That's my gradient. But I don't know this bit yet. So I need to find this part. So if you are not given the x coordinate as 0, here's what you do. You now pick any one of those two coordinates. So I'm going to choose this one, 2, 5. Remember, with my coordinate of 2, 5, that's your x value, that's your y value. So let's substitute in those two numbers into this equation. So y is 5, so I take this y and change it for 5. 2x means 2 times by x, and x over here is 2. 2 times 2, and then I don't have any values for c, so I call that plus c. So now what we say is 5 is equal to 4 plus c. And remember, what you're trying to find is you are trying to find this part here. That's what you're looking for, the c part of your equation. So you need to get it on its own. So all you do is you take this 4, put it over there. To rearrange that, if you're moving it over the equal sign, it changes from a positive, which it is at the moment, to a negative. So you're saying 5 minus 4 is equal to c. So c is therefore equal to 1, because 5 minus 4 is 1. So your c value becomes 1, and you basically take that, put it up there. So you say y is equal to 2x plus 1. That's a little bit harder, because as I said here, we don't have any 0 values, whereas up here we did. So if you get these questions where you're asked to find the equation of a line, if you're given the graph, draw your triangle between two coordinates, make sure your triangle is drawn properly, choose your two coordinates, do your change in y divided by change in x. If you're not given the graph and you're given just coordinates like this, set them out above each other, find your difference in y, find your difference in x, substitute into the formula, work it out from there. Hope you found that useful, and I will see you all in the next video.